Today's topic is oxidation and reduction in general principles of isolation of elements. Beside reduction, some extractions are based on oxidation, particularly for non-metals. A very common example of extraction based on oxidation is the extraction of chlorine from brine. Chlorine is abundant in seawater as common salt. Here is the reaction. Cl plus 2H2O gives you 2H plus H2 plus Cl2. The delta G naught for this reaction is plus 422 kilojoules. When it is converted to E naught, fusing E naught, delta G naught is equal to minus N E naught F. We get E naught is equal to minus 2.2 volts. Naturally, it will require an extreme EMF that is greater than 2.2 volts, but the electrolysis requires an excess potential to overcome some other hiding reactions. Thus, Cl2 is obtained by electrolysis, giving out H2 and aqueous NaOH as byproducts. Electrolysis of molten NaCl is also carried out, but in that case, sodium metal is produced and not NaOH. As studied earlier, extraction of gold and silver involve the leaching the metal with cyanide, and this is also an oxidation reaction where silver is converted to silver ion and gold is converted to gold ion. The metal is later recovered by the displacement method. Here are the reaction. Gold plus cyanide ion plus water gives you oxygen. It is AuCN auric cyanide plus 4OH, and then this auric cyanide is reacted with zinc to give gold metal and zinc cyanide. In this reaction, zinc acts as a reducing agent. Now the next topic is refining. Refining. A metal is extracted by any method is usually contaminated with impurity. For obtaining metal of high purity, several techniques are used depending upon the difference in properties of metal and the impurities. Some of them are listed below. These are number 1, distillation, number 2, liquefaction, number 3, electrolysis, number 4, zone refining, number 5, vapor phase refining, and number 6 is chromatographic method. These are described in detail here. Number 1, distillation. This is a very useful method for low boiling metals like zinc and mercury. The impure metal is evaporated to obtain the pure metal as distillate. So this method is used for low boiling metals. Second point, liquefaction. In this method, a low melting metal like tin can be made to flow on a sloping surface. In this way, it is separated from higher melting impurities. So note about the principle of the refining methods. In distillation, what is the principle? It is used for low boiling metals. For liquefaction, it is used for low melting metals. Third method is electrolytic refining. In this method, the impure metal to act as anode and a strip of same metal in pure form is used as cathode. They are put in a suitable electrolytic bath containing soluble salts of same metal. The more basic metal remain in the solution and the less basic one go to the anode mud. This process is also explained using the concept of electrode potential over potential and Gibbs energy, which you have seen in the previous section. The reactions are: at anode, metal is converted into M ions with the liberation of electrons